This video covers chapter 14 of the GCSE Higher textbook, and pretty much this is about powers and standard form. Now, when we talk about rules for powers, you might see this index form. That's because when we have some sort of number and we have a power here, let's say power 7 next to power 7, this can be called the power, or the index, or even sometimes you might see exponent. That's why sometimes when you do standard form, you might see a button that says exp on it. That's where it comes from. Okay, and what we're going to look at is our rules for powers. Okay, so the first thing, some special powers. So for example, anything to the power 0 is 1. Anything to the power 0 is 1. Anything to the power 0. Okay, here's an example. 52 to the power 0, guess what it is? It's 1. Okay, second rule. Anything to the power 1 is itself. Okay, power 1 doesn't change anything. So power 1 doesn't change anything. And that's useful because sometimes you want to take something and we want to write it as power 1. Okay, just tighten up my writing. So power 1 doesn't do anything. Here's an example, e.g. 12 equals 12 to the power 1, or 3.2 to the power 1 equals 3.2. So you can use the rule either way around. Okay, so these are things that, it's not really rules, but these are things that always happen to any number, or even if you had a letter there. Okay, how about some other rules? Well, we've got a rule here for when we multiply. So when we've got something to a power times something else to the power, the rule is that we add the powers. So you could think, okay, when we multiply here, we add here. Yeah. If I've got two things and I'm dividing, so I've got this, or it may be written like this, a division, like as a fraction, then what we do is we subtract the powers. So just be careful when you're subtracting negatives here, because the second thing might be negative and you're subtracting negative power. So here we divide and here we subtract. This might be useful later on. And another rule is that when you've got something to a power and that's to another power, what we do is we multiply the powers. And one more rule, anything to a negative power is equal to 1 over the positive power. So let's do some examples of each one of these. So first one here, so if I had 6 cubed times 6 to the power 5, that becomes 6 to the power 8, because you just do 3 plus 5. Here, if I had 3 to the power negative 7 times by 3 to the power negative 5, then this becomes 3 to the power, now I've got this, I'll break it down here, negative 7, then you've got to subtract minus 5. So actually, that's the same as adding 5, so that becomes 3 to the power negative 2, because you basically got negative 7 plus 5. Here's an example one down here. Let's say I had 12 to the power 5, that was in brackets, and that was to the power 4, so that becomes 12 to the power 20. You just do 5 times 4. If I had 5 to the power negative 3, that will be the same as 5 over 3 cubed, and actually, sorry, 5 cubed, and 5 cubed is 125, so you can write it like this. Here's another one. If I had, let's say, 3 to the power negative 2, that's the same as 1 over 3 squared, which is 1 over 9. So sometimes you can do that. I mean, you know, if I had something like this, 7 to the power negative 12, okay, I'd write it as 1 over 7 to the power 12. You know, that's probably not something I'd be able to work out, 7 to the power 12. really, I'd need a calculator for that. So that's the first bit. So we've covered these two bits here. Yeah, and we're actually going to look at a couple of ways that we can apply some of these rules. So here's something that you might have. If you get a question that says you need to write something in index form, it basically means that you need to write it using powers. Yeah, so for example, if I wanted to write 8 in index form, I'd write it as 2 cubed, something as a power. If I wanted to write let's see, 27 in index form, I'd write it as 3 cubed. If I wanted to write 16 in index form, I'd write it as 4 squared. Now what we can do is we can use things like this to help us with other problems. So here's an example. So let's say I had something like 4 to the power -3, and I need to write it as 2 to the power something. So the first thing that we do is we take the thing in the brackets and we write it as 2 squared. Everything needs to be written as 2 basically, and then that becomes 2 squared in the brackets. So since we've got a power of a power, we multiply the powers, that becomes 2 to the power -6. So in this case, n would be -6. Here's another one. Let's say I have something like 32 in brackets here, and this was to the power, let's say negative, let's not make it negative, let's make it positive. Let's say 4, and I needed to write this in the form 2 to the power m. I need to work out what m is. Well, the first thing is you take the thing in the brackets, you write it as 2 to the power of something. Now 32 is actually 2 to the power 5. 2 times itself 5 times, so that's what goes in the brackets. That to the power 4, and then what we do is we multiply the powers, that becomes 2 to the power 20. We can apply these rules to multiple things. Now they don't necessarily need to be numbers, they could be letters. So I could have something like this. Right, so on something like this, I'll work out the top, which means I add the powers. So that'd be 7 plus -3, which would just be 7 minus 3, which is 4. Now at the bottom, it just says a. Now that's not a to the power 0, that's a to the power 1. Any letter on its own like that, or number on its own, is power 1. So if I add the powers, I've got -4 plus 1, a to the power -3. Now from here, I subtract the powers. So basically it's a to the power 4 minus -3, because I'm dividing, I subtract the powers. That becomes a to the power 7. So these rules can be applied in one question. So you could be using rules for power 1, power 0, multiplying, dividing, or even powers of powers. Okay, so next thing we're going to be looking at is standard form. Converting numbers from standard form to what we call decimal form, and doing calculations with standard form. So the first thing is that standard form is used to represent or display large and small numbers. It's handy because we don't need to write loads of zeros out, and it saves people making mistakes. So standard form is always written like this. You'll have a to the power a times 10 to the power b. So this number here, a, must be between 1 and 10. It can't be 10, it can be 1, but it must be between 1 and 10. So it could be 5.2, 3.14, it couldn't be 10, it couldn't be 52, it's got to be a number between 1 and 10. And then this represents the number of jumps, okay, the jumps of the decimal point, and you'll see that in a moment when we go through some examples, the jumps of the decimal point. So let's start by converting from what we call decimal form. So this is normal numbers, decimal form to standard form. So this is converting normal numbers to this standard form numbers. So here's some examples. So let's say I've got 2,300, and I want to convert that to standard form. Well, the first thing that we need to do is we need to look at where the decimal point is, and it's actually here, and we need to move it to a point so it turns the number into a number between 1 and 10. So it needs to move to here, and I'll achieve that by moving it 3 jumps that way. So in standard form, that would be 2.3, so that now turns it into a number between 1 and 10. This is always here, this times 10 to the power of, and then the power is the number of jumps, and it was 3 jumps. Okay, any large number, the number of jumps will be a positive number, so it's not -3 for this. For any small number, and we'll do one in a moment, the number of jumps will be a negative number when we put that in. So here's another one. Let's say I've got 0.00421. I'm going to write that in standard form. Well, the decimal point is currently here, and I want to move it to here. That will make it between 1 and 10. So I've got 3 jumps again. When I do the 3 jumps, I get the number 4.21 times 10 to the power of, that's always there. Now, I know it's 3 jumps, but it's negative because it's a small number, a decimal number. So negative powers for small numbers, for those decimals, and positive powers for those large numbers, those numbers bigger than 1. Any number smaller than 1, a decimal number, has a negative power. So that is converting decimal form to standard form. Now let's do the opposite, which is converting standard form to decimal form. So this is the opposite to what we did. So here's a couple of examples. Let's say I've got 3.1 times 10 to the power of 5. So I need to do some working. So what I'm going to write in purple is the working, it's not the final answer. So I'd write 3.1. I would do 5 jumps. Now I'm going to do 5 jumps that make the number bigger. Yeah, because it's a positive 5. That means jumping to the right. So 1, 2, 3, 4, 5. It jumps to there. Now I can't just leave all these little things empty. These little hoops, these little baskets. I need to put an egg in each basket. So think of like these little hoops sort of that just go above it. And think of those as like little things here that you need to fill with eggs, and each 0 is an egg. Now this is my working. Obviously I don't have 2 decimal points in my answer. The decimal point will be at the end, and that will leave me with the number 310,000. So 310,000. Okay, here's another one. Let's do one where we've got a negative power. So let's say I had 5.021 times 10 to the power of -6. Okay, so again I need to do my working. So I'm going to write the number 5.021. This time there are 6 jumps. Now it needs to jump in a direction to make the number smaller, which means it needs to jump to the left. So 1, 2, 3, 4, 5, 6 jumps to there. Under each little hoop I need to put a 0. So I've got like little things here that I need to put the zeros in. Each little hoop there. Now that's my working. Obviously I can't leave my answer like that. Can't just put point. We need to put a 0 in front. And then I have 5 zeros. 0, 1, 2, 3, 4, 5. And then the 5021. So that's converting from standard form to decimal form. The last thing we need to do with standard form is to be able to do calculations. So we'll look at multiplying in standard form, first of all. Now when we multiply in standard form, you take your numbers that you have and you're going to multiply the numbers in the standard form, and you're going to add the powers. If I need to divide in standard form, going to do the opposite, which is going to be to divide the numbers and subtract the powers. There we go, subtract the powers, stop working for a second there. And if I need to add or subtract in standard form, add, subtract, standard form, there is no rule. We basically just need to convert the numbers to decimal form. So step 1, convert numbers, standard form numbers, to decimal form. Okay, then you add or subtract as normal, add or subtract as normal, and then whatever number you get, you convert back to standard form. So we'll do some examples of each type. So multiplying numbers in standard form. Oh, and also there's something called an adjustment. We'll talk about that in a moment, that we may need to do, because the number that we have at the beginning of the standard form may not be a number between 1 and 10, and we need to adjust it to make it a number between 1 and 10. Right, so let's do a couple of examples of each. So multiplying in standard form. Let's do 3 times 10 to the power 7 times by 2 times 10 to the power 8. Right, so we multiply the numbers, so that's 6, 3 times 2 is 6, and then we add the powers, 7 plus 8, 15, that's it, done. Okay, here's another one. Let's say I've got 9 times 10 to the power negative 3 times by 4 times by 10 to the power of negative 6. So I multiply the numbers. Now 9 times 4 is 36. Then I add the powers, so that's going to be negative 3 plus negative 6, which becomes negative 3 minus 6, which is negative 9. Now this isn't quite in standard form, because if you look, this number at the beginning is not between 1 and 10. So this is where we do the adjustment. So I'll just put adjust. And the way we're going to adjust it is we need to make the number smaller by doing one jump of the decimal place. So what we do to keep it all balanced, we add 1 to the power. So if we do that, the 36 will become 3.6. I've made it smaller, but I can't just change that on its own. To keep it balanced, I need to make the power bigger, so I add 1 to the power. So that would be 3.6 times 10 to the power of negative 8. So that would be my final answer. Let's have a go at some division. So let's say I have 4 times 10 to the power of negative 5 divided by, let's do, what can we divide that by? That's going to be, let's do 8 times 10 to the power of 4. Right, so I divide the numbers, so 4 divided by 8 is a half, or 0.5. Then I do negative 5 minus 4, which will give me negative 9. Now on this one, like the last one, I need to adjust, because that number at the front there is not between 1 and 10. I need to make it bigger, and I'm going to make it bigger by doing one jump of the decimal place, which means I need to make the power smaller by 1. So if I do that, I will get 5 times 10 to the power. If I've got negative 9, I'll take 1 away, negative 10. So it's the same number as the previous one, but now this is in proper standard form. Now sometimes we need to do this adjustment without actually having to do a calculation. So let's have a look at a couple of adjustment calculations so that you get a bit more practice. So if I had something like this, 573 times 10 to the power of 7, and I need to change that to standard form. Well, the number is too big. I make it the right size by moving the decimal point 2 places to make it 5.73. So I put 2 arrows going down to show me that I moved the decimal point 2 places. So since I've made the number smaller by 2 jumps, I need to make the power bigger by 2. So this is the same as 5.73 times 10 to the power 9. So you can have multiple jumps. It doesn't need to be one, but for every jump, then the power in standard form needs to go up or down. Let's have a look at adding or subtracting in standard form. So if I had something like 2.3 times 10 to the power of 4 plus 5.7 times 10 to the power 3, okay, what we do is we convert these into normal numbers first. So the 2.3 times 10 to the power 4 would actually be 23,000. 1, 2, 3, 4, yeah. And then the 5.7 times 10 to the 3 would be 5,700. So I'll just check 3 jumps, 1, 2, 3, right? And then we just add them like normal numbers, like this. And then I turn this back into standard form. So it's going to be 2.87 times 10 to the power of, how many jumps do we have? 1, 2, 3, 4 jumps to the power 4. So this is how we add and subtract in standard form. The last thing we're going to look at is how we use a calculator. Now on your calculator near the bottom you'll have the equals button, you'll have a button that says ANS where you can store answers, and next to that there'll be a button that says times 10 to the power X, or it might say, if you've got an older calculator, EXP. This is our standard form button. Okay, so the standard form button on our calculator is this button here. Most calculators now have a button like this. Now what we do, this will put in the middle part of the standard form for us. So if I wanted to type in 4.2 times 10 to the power of 7, what I'd actually type in on a calculator is 4, then point, then 2. Then I don't need to do times or anything like that. I now press this button here, times 10 to the power of X. Then I type in the power. So I just type in 7 and there it is. Okay. If I had something like 3.71 times 10 to the power negative 3, then I would type in the 3.71 like this, then the standard form button. So I don't need to do times or 10 or anything like that, and then the power. So I'd have to press the negative button there and then the 3. So this covers everything that you need to know to do with the rules for powers and working in standard form. There will be some more rules for powers, but that comes in one of the later chapters.